Hi, this is our presentation for CS364. My name is Tyler Willis, and I will be talking about the advantages and disadvantages. Landon will be talking about the definition of the factory pattern and when to use it, and then Mosiah will be giving a demonstration on how to use it.
The source mentioned below says that the intent of the factory method is to define an interface for creating an object, but allow the subclasses to decide which class to instantiate. The factory method allows a class to defer instantiation to the subclasses. Later we will see why this is useful.
Here are some advantages of the factory pattern. The first advantage is that it prioritizes the creation of objects. This is really helpful in situations where large numbers of objects need to be created and destroyed regularly, because that there are objects that are specifically designed to create and destroy them. It's also helpful when creating complex objects. There's loose data coupling, which means that objects are less dependent on each other, which is helpful for lots of different aspects. Specifically for abstract factories, they allow separate objects to be created by the same factory, which abstracts away constructor details from the subclasses. Similar but different objects can be created simultaneously from the same factory, which can be a good thing if you need lots of really similar but not exactly the same objects to be created. It also enforces good coding practices just like any other design pattern. It won't work if it's not coded well. Here are some of the disadvantages of the factory pattern. Code is less readable. Since all code is hidden behind an abstraction, it's hard to visualize how the code is working. It's also less linear because of the abstractions, and it's harder to follow. It's also very situational. It can be used in certain specific situations, but not in most. In some cases, it's very helpful and very easy, but in others, it can just cause more problems than it solves. It can also be used incorrectly very easily. In many cases, there's also decreased performance because of the loose data coupling. Specifically for the simple factory, another disadvantage is that the simple factories can only create one type of object. In the case where many similar objects need to be created, under the simple factory pattern this is impossible, so the solution is to create more factories, which can clutter up your code and become a problem.
The article cited below on the slide states that the factory method is most appropriate to use when the complex behavior of a class should be changed in the subclasses. It should not be used to override the entire code implementing this behavior, but its changeable part should be defined as a separate product class. The complex behavior to be changed in the subclasses is defined by the AND operation method of the creator class. The article goes on to list a few other conditions that should be met for the factory pattern to be useful. First, if a class cannot anticipate the class of objects that it must create, this might be because a user might have a few options to select from for creating the object. Second, a class wants its subclasses to specify the objects that it creates. Third, a class delegates responsibilities to one of the several helper subclasses. Some of the functions should be overwritten by the subclass, but not all of them. Fourth, it is necessary to localize the information on which of the subclasses is the delegate.
Hi, my name is Mosiah and I will be narrating over the demonstration section. We will demonstrate how we can use the factory pattern on our current project through Java. Here are the steps that we will follow. Create a user interface. Create concrete classes implementing the user interface. Create a user factory to generate object of concrete class. Use user factory to get objects of concrete class by passing a string. We want to create an interface named user because we will have many types of users that would share similar methods. I'm sure that there will be many methods that we can include in this interface. However, we wanted to keep it simple and easy to understand, so we felt that one method will suffice for this demo. In step 2, we want to create a concrete class for each type of user. We will have a bishop, a home teacher, and a visiting teacher. Because each class is using the user interface, each will have a display method. We can override the display method so that each of the display method will vary depending on the class. In step 3, we will create a factory to generate objects of type user. A specific user can be created based on the parameter passed in the getUser function. Passing nothing will return null. Passing bishop will return a bishop. Passing in a home teacher will return a home teacher. And passing visiting teacher will return a visiting teacher. Step 4 shows how everything comes together. We have a demo program that shows how to use the factory we just created. We can see that the user factory is creating different types of users based on what the client passes as a parameter. This is an elegant way to create objects. It is easy enough to implement and understand. This is the beauty of the factory pattern.
In summary, the factory method is used by creating an interface that creates subclasses for the user. The advantages to this method are that they eliminate the need to bind application-specific classes into your code, that the code will only deal with product interfaces, allowing a user to create concrete product classes, and that factory methods connect parallel class hierarchies in such a way that it localizes the knowledge of which classes belong together. Some disadvantages of the factory method is that clients might have to subclass the creator class just to create a particular concrete product object, and that the factory used for creating the objects is bound with the client code, making it difficult to use a different factory for creating objects. We recommend using factory methods when a class cannot anticipate the class of objects it must create, when the class needs subclasses to specify which objects they create, when a class delegates responsibilities to its helper subclasses, and it is necessary to localize the data on which the subclasses' responsibilities are being delegated.